This is the second example for a difference of squares problem. So let's try x to the fourth minus 25. Again, remember to try and find the greatest common factor between your terms, but there doesn't have one between x to the fourth and 25. So now what we're going to see is this x to the fourth a perfect square, and is the 25 a perfect square. Anytime you have an even exponent, that means it is a perfect square. So this x to the fourth is a perfect square. And the reason is x squared squared is x to the fourth. 25 is a perfect square because 5 squared is 25. So the important thing to remember, a squared minus b squared equals a minus b times a plus b. There's our rule. And now we can just substitute the sum and difference of their square roots. So it's going to be x squared minus 5, x squared plus 5. You want to double check each parentheses to see if this rule will keep applying over and over again. This parentheses is close because this is a perfect square, the x squared is a perfect square, but the 5 is not a perfect square. So we cannot use the rule again. In some problems we're able to keep going. But for this particular one, x squared minus 5 times x squared plus 5 is our solution.